In this module, we are going to discuss the Firewall Overview and configuring the Firewall Options. The module goals for this module that you will learn is that you will identify the purpose of the Firewall module. You'll distinguish between the two different types of firewall policies and know how to configure the settings in the Firewall Options policy to meet your customer requirements. An overview of the key features of the Firewall Options is that it is a host-based firewall protection. This should be your last line of defense, not the first line of defense, but the idea is the fact that if my machines are outside of our network, we can have a specific firewall policy. Part of the fact that what this firewall can do is it has stateful packet tracking. So what we have is a stateful firewall where it will track any TCP, UDP, ICMP type communication. It examines each one of the packets. If you have a matching existing allow rule, then it automatically will be allowed and you'll have an entry in the state table. The state table will dynamically track your connections that were previously matched against any static rule set and will reflect the current state of the connection having to do with these protocols. If an inspected packet matches an entry that exists in the state table, the packet is allowed without further scrutiny. When a connection is closed or it times out, that entry will automatically be removed from the state table. We will talk about more about this later on. Just understand, when you're using IPv6, that's the stateful functionality is only supported on Vista and later operating systems, including Windows 7, Windows 8, Windows 10. We also have the stateful packet inspection. It will do the stateful packet inspection at application layer 7, and it will combine the stateful packet filtering and tracking and give you a better definition of your computer's connection state. This access provides error-free inspection and securing of any Ftp, Dhcp, Dns type protocols. It will inspect the incoming packets to ensure they correspond to an outgoing request and rejects any unsolicited and harmful packets. In the network architecture, the desktop firewall addresses all the layers of the OSI model. It will look at the incoming packets, make sure they do correspond with your outgoing request, and rejects any unsolicited and possibly harmful packets. As I said to you before, it does provide inspection of the FTP protocol, DHCP, and DNS, and it will dynamically track and reflect the state of your internet protocol having to do with these different types of connections. The state table tracks all the connection states of our different communication. It will dynamically store all the information about all the active connections that are created by your allow rules. The different entries that defines and it's matched on is based having to do with what protocol. Is it talking TCP, UDP, ICMP? What is the local or remote IP addresses of the computers or systems? Also, the local and remote computer port numbers. So an example would be like HTTP talks on port 80, FTP talks on port 21. The port numbers range from 0 to 65,535. The process ID, the PID, would be the unique identifier for the process that is associated with that traffic. The timestamp, when was it that it last came in or it left, having to do with this connection. The timeout is in seconds. We can set that in the Firewall Options policy that you can change from the default settings, and once it hits that timeout, then the entry is removed from the table if we don't have any more packets matching that connection. And then the timeout for TCP is enforced only when the connection is not established. We also have the direction. Is it incoming or outgoing? The connection information will be removed from the state table in these situations if you have where the firewall rules change. all the active connections that are checked against the new rule set, it will re-examine those and automatically remove them. A good example of that would be, let's say you created a policy, you added a new rule in EPO, and your machine checks in with EPO, downloads that policy, then it will check all the rules, and if there is a connection that is breaking that rule, it will automatically be removed at that time. Another example of where it will be removed is if the adapter gets a new IP address. So here's, because what it will do is it'll say, oh, you have a new IP configuration, so what I'm going to do is whatever's in the state table gets flushed out completely and we'll start all over. A good example I have of that is, let's say you were connecting up to a wireless network in, let's say, a hotel, and you didn't realize, but you connected up to, a really bad wireless network. So you disconnect, and then they tell you, oh, no, this is the wireless network you're supposed to connect to that has to do with the hotel, and you connect to that one. So at that point, the firewall says, oh, well, let's get rid of all these previous connections. So now what we're going to do is re-examine all the rules. We also have, once again, any entries. Let's say I've opened up Internet Explorer, I've connected up to the company website or another website, do whatever it is I'm going to do on that site, then I close Internet Explorer. Well, the process has ended, and everything, all the entries in the state table will now be deleted. The stateful protocol tracking, the types of communications that we do monitor with the stateful firewall. First off, you have UDP. It will match any static rule. Just understand, UDP is a generic connection. They carry application level protocols that are unknown to the firewall. If you have those, they remain in the state table as long as the connection is not idle longer than that specified timeout. Many times whenever I talk about UDP, a good example of UDP is, the checks in the mail. I have not actually done an actual connection. I've just put it in the mailbox, hope it gets there. ICMP, the only communication that is tracked is ICMP echo request and echo reply. Any other ICMP connections that are managed will be like generic UDP connections. Just understand, these two communication types are less reliable. They're considered connectionless protocols. That's why I say check is in the mail. I don't know if you received the check. There we go. And once again, that connection will be held only until it's not idle longer than the configured policy settings. To continue talking about the stateful protocol tracking, TCP, if you'll recall, it works on the three-way handshake. So when your client initiates a new connection, it'll send a packet to its target with that send bit, indicating a new connection. The target responds by saying a packet to the client with a send acknowledgement bit set. Then the client responds, sending another packet with an acknowledgement, and a stateful connection is established. After that, all the outgoing packets are allowed, but only incoming packets that are part of the established connection will be allowed. An exception will be when the firewall first queries the TCP connection protocol and adds all pre-existing connections that match the static rules. Pre-existing connections without that matching static rule will be blocked. The Tcp Connection Timeout, which is set in our Firewall Options policy, is enforced only when the connection is not established. We do have a second or fourth TCP timeout that it applies to your established TCP connections only. This timeout is controlled in a registry setting and has a default value of 1 hour. Every 4 minutes, the firewall queries the TCP stack and discards any connections that are not reported by TCP. For DNS, we'll have a query and response matching each DNS query and response. And of course, these are only allowed to the local port that originated the query and only from the remote IP address that it queried, having to do with that UDP connection. And then we still have our connection timeout. The incoming DNS response are allowed if the connection in the state table has not expired, and of course the response came from that same remote IP address and port where the request was sent. The stateful protocol tracking with Dhcp will happen when we have a query and response to make sure the return packets are only allowed for legitimate queries. So as your Dhcp responses come in, they are allowed, again, if the connection in the state table has not expired and the response transaction ID matches the one from the request. A packet comes to your machine. Either it's going out or it's coming in. So what it will do is it will process the packet against two rule sets. You'll have your firewall rule set and the dynamic rule set, or what is in the state table. So what happens is you have two types of actions, allow or block. So here's how the steps work. Here comes the packet. Firewall looks at the incoming packet against all entries in the state table. If you have a match in the state table, then it is immediately allowed. If it's not, then it has to examine the firewall rules. Basically what happens is if it finds an allow rule, then it's obviously allowed and it is added to the state table. If it's blocked, then it's automatically blocked. If it does not match any rules in the rule set, then it is also blocked. The firewall policies that exist in EPOs, you have two types. You have an options policy where we set the protection, the tuning, and other types of settings that we're going to discuss. The other section is the rules, and it can be a user-based policy, which we'll talk about later. Once again, you have the Mcafee default and the my default for the different types of policies. But with the rules, we also have another one, which is the Mcafee default server, which is a read-only rule set. An overview of what we're going to now discuss is the key features of the firewall options, having to do with the protection options, the tuning options, and examples are adaptive mode, our GTI, where we have the IP and the network reputation, the stateful firewall, the firewall status control, our DNS blocking feature, the defined networks, and our trusted executables. An overview of the firewall options policies. If you recall, I can go into the policy catalog, and once again you have the Mcafee default and the my default. You can duplicate these, or you can edit the one that is the my default to get yourself started or create your own. For the protection options of the endpoint security firewall, the top part is first you want to enable the firewall. The second one is allow traffic for unsupported protocols. By default, this is disabled. If you want to enable this, that would be where you're going to allow traffic using unsupported protocols. If you have that deselected where it's not selected, that means if there's an unsupported protocol that's trying to communicate with your particular machine, it will automatically be blocked. Another option that we have is allow only outgoing traffic until the firewall services have started. By default, this is enabled. What this means is my machine can communicate out. At least it will receive its DHCP address, it will find the network, all of that types of communication. If you want to, you can disable this to allow all traffic before services are started. Caution, if you do have it disabled, then basically that means all traffic can communicate with your machine, both to and from, before the services are started, which might leave your system vulnerable. The idea of this is only allow communication that's initiated from this machine to be allowed, not communication automatically coming to the machine. The allow to bridge traffic, by default this is disabled. The idea of this is this would be if I had a server who was running numerous virtual machines, you could go in and have where I can allow incoming packets and traffic if the destination media access control address is in the list of supported virtual machines that is on that particular server, and it's not the local MAC address of that particular server. It will allow all outgoing packets if the MAC address is in the supported MAC address range and it's not the local MAC address of that particular system. Enable IP spoof protection. By default, this is disabled. It will block network traffic from any non-local host IP addresses or from the local processes that attempt to spoof their IP addresses. Enable dynamic block rules. By default, this is disabled. This is where we would actually go in and have where the ENS create and add blocking rules dynamically on the client. Enable firewall intrusion alerts. By default, this is enabled. It will actually display any alerts when the firewall detects a potential attack. The tuning options to enable or disable these options. First off, we can enable the adaptive mode, which we'll talk more about later. The default is disabled. To enable this, what you're doing is you're allowing clients to automatically create client-side rules so that we can upload those rules and you can actually add those rules to policies. It's very helpful for your tuning. After you have what we say client rules, after they were created, then you can look at them and decide whether or not I want to convert that rule to be a server mandated policy from EPO. Just understand, systems in adaptive mode have no protection except the policies that it's received from the EPO server. You have the option of disable Mcafee core networking rules. By default, this is disabled. If you enable this, then you might disrupt any network communications on the client. It is not recommended that you enable that. Log all block traffic is enabled, so we'll get everything logged to a firewall event log, which is firewall event monitor.log on the client. And log all allowed is disabled by default. It would be logged to that same log if you want to. If you go in and select that, you might negatively affect the performance of your machine because it will be logging every allowed traffic, and that could be a lot of data. Using adaptive mode. Ideally, this is intended for your test environments and before you actually do your rollout. When you enable this, what it does is it automatically creates rules to allow any activity while preserving any protection for any vulnerabilities. You can take these rules and add them to your policy. The thing about it is what you want to do is, first off, you want to define your pre-existing firewall rules, because the adaptive mode policy will not create a rule if you already have a pre-existing rule. So often in large organizations, avoiding disrupting your business will take priority over security concerns. So maybe I need to install some new applications on some computers. I don't have the time or resources to tune them, so I can put those specific computers in adaptive mode to try to define that newly installed application. You'll receive the resulting client rules up on your EPO server, and then you can promote those rules to your policy or create a brand new policy to use those rules. Just understand, you can create a large number of client rules, and this could actually affect the overhead of your EPO server. So it's not recommended that you do this, enable this for a large number of machines on your network. On this screen, we're showing you an example custom use case that was assigned to a particular group in the system tree that's called Texas. We'll select Menu Reporting, Firewall Client Rules. Basically, adaptive mode is automatically going to create rules that allow the traffic. In this figure, we have this group that has a policy where all the rules except the Mcafee basic and core networking rules are deleted. So you can see it will automatically create all of these rules based on the traffic. I can take these rules and then add them to my policy. Best practices for using adaptive mode are that you should always use this temporarily on a small number of systems. If you recall, I mentioned to you before, it could actually add a lot of overhead to your EPO server. The EPO server has a server task that runs in the background that translate these rules. Be sure that you run at least once a week, like less a month, to account for all your normal activity. Make sure you have times for any scheduled activities like backups, script processing that might be needed to be detected. Be sure you have this retain client rules selected. When you have the retain client rules, it will retain it locally on the local machine. It will also upload them to your EPO server. You can look at the rules in EPO. You can analyze the rules, decide which ones you want to implement, and add them to your policies. When you're done, be sure to turn off the adaptive mode and be sure to turn off retain client rules. Disable that. When will an adaptive rule be created? Well, first off, you don't have an application associated with the packet. Or, what's very, very important, you already have an existing allow or block rule. Another would be you have a location enabled firewall group where the connection isolation is enabled and your active network interface card matches that group, and the packet is sent or received on the NIC that does not match that group. So we will not create an allow rule. Also, the packet is not TCP, UDP, or ICMP. Another way that it's not done is you have more than one user logged onto the machine or no one is logged onto the machine. If you recall, I did mention to you that there is a server task that runs in the background that translates all of those client rules. It's referred to as Firewall Property Translator Server Task. This runs no matter what you do. You cannot actually disable it, but what we have done is we have created a task that is not enabled in the server task features of EPO. Please do not configure this task. This task in that server task setting is only there for you to be able to run it as needed. So you can go in and do a run now. Otherwise, just leave it alone. What happens is the background task is going to look at all these client rules and it will automatically translate them so that you can look at it in the database tables with all the content that has to do with that particular firewall rule. We do have a KB article that we recommend that you look at. It's KB 73399. And even though it does reference host intrusion prevention, it is relevant to ENS. Configuring the Mcafee GTI, please understand this is for Windows only. This will determine whether or not you have good or bad behavior that is being communicated to and from your machine. It makes for like a dynamic block or allow rule having to do with the IP address on the internet. Just recall, Mcafee GTI, we maintain a reputation value for each IP address on the internet. It will base that value on the sending or hosting behavior and various other environmental data that we collect from customers and partners about the state of the internet threat landscape. The reputation is expressed in 4 classes based on our analysis. The reputation is expressed in do not block, which we just don't even block because it's a legitimate source or destination. High risk, the source and destination is known or to likely have been sending potentially malicious content and traffic. It's believed to present a very serious risk to your network. Medium risk shows, well, this risk shows behavior that we believe is suspicious and it requires special scrutiny. Unverified, it appears that it's a legitimate source or destination of content in the different traffic. However, The site also displays certain properties that suggest we might have further inspection that is needed for that. So you select basically what is the threshold that you want it to block at. How does a trusted GTI source work? Well, we use a network reputation threshold. And what it does is it uses the value of your incoming requests and outgoing requests to determine what is the threshold of our network, and then it will create some internal rules on the client system. If our incoming or outgoing traffic matches these rules, then it will query the Mcafee GTI for the reputation of the source or destination IP address. The firewall will use this information to determine whether or not to block incoming or outgoing traffic. If you have the log matching traffic option enabled, then the block events are logged and sent to EPO. If you have treat Mcafee GTI match as an intrusion option enabled, the block events are also treated as intrusion events and appear as alerts on the client system. The trusted source provides ratings for a variety of the communication mechanisms, including your network connections, the URLs, email messages, and spam. Mcafee Labs collects information from billions of IP addresses and network ports, providing hundreds of trillions of unique views, and calculates a reputation score based on data about network traffic, including port, destination, protocol, and inbound and outbound connection requests. This score will reflect the likelihood that that network connection poses a threat. For example, it is associated with botnet control. The score is based not only on collective intelligence and analysis by Mcafee Labs, but also on correlation of cross-vector intelligence from file, web, and network threat data. The local security product, whether it being firewall or intrusion prevention system, will use this score to determine the action based on our local policy. The key benefits of this protection is that we will protect you against botnets, a distributed denial of service attack, command and control activity, advanced persistent threats, and any risky web connections. It also reduces the system and network burden by blocking threats at the network edge. And it will decrease the downtime and remediation costs associated with any of your network-based type of attacks. So how does this work? Well, when the trusted source options are selected and a connection is attempted through the firewall, the trusted source is contacted and the reputation of the connection is looked up. If the connection's reputation is equal to or worse than the specified reputation threshold, the traffic is blocked. If the client machine running ENS firewall performs a trusted source reputation request against the connection, then if it cannot reach any of the trusted source servers, it will automatically assign any of the connections that apply with a default reputation that is allowed, and an analysis of the rules will continue to follow through the policy. Is there any GTI latency? There could be some GTI latency. It just depends on what happens. We try to minimize everything possible. Mcafee's GTI only checks reputations when the options are selected, and it uses an intelligent caching architecture. In normal network usage patterns, the cache resolves most of the wanted connections without a live reputation query. The principles of our global threat intelligence is that we maintain a footprint that spans the internet, including millions of sensors gathering real-world threat information. It gathers and collects data from and across all threat vectors, including the file, web, message, and network. It ensures that the data collection and threat intelligence distribution are cloud-based and performed in real time. It also delivers reputation-based threat intelligence. It integrates threat intelligence into a complete suite of all of our security products. And it supports the entire process with a global research team that is dedicated solely to threat intelligence. If you want to read any more information about our global threat intelligence, see our KB articles. We have KB 74983. We also have KB 53735. and then another one KB 71000. Configuring the stateful firewall is the same, or we can have different rules for the different FTP connections. So what we can do is the stateful firewall allows the tracking of any FTP connections to be tracked, so all we have to do is have one firewall rule for any outgoing FTP traffic and any incoming FTP traffic. If you select Use FTP Protocol Inspection and you have it disabled, then you will have to create a separate rule for incoming FTP client traffic and outgoing FTP traffic. FTP inspection is performed only when packets that carry new information are being transmitted. Any retransmitted packets will be ignored. Our stateful packet inspection will combine the stateful filtering with access to all of our application level commands, which secures protocols such as FTP. Please note, FTP involves two connections: control for commands and data for the information. When a client connects to an FTP server, the control channel is established, arriving on FTP destination port 21, and you'll have an entry made in the state table. If the option for FTP inspection has been set with the Firewall Options policy, then when the firewall encounters a connection open to port 21, it knows to perform the stateful packet inspection on the packets coming through the FTP control channel. With the control channel open, the client communicates with the FTP server. The firewall parses the port command in the packet and creates a second entry in the state table to allow the connection. When your FTP server is in active mode, it opens the data connection and allows a connection. In passive mode, the client initiates the connection. When your FTP server receives the first data transfer command, LIST, it opens the data connection towards the client and transfers the data. The data channel is then closed after the transmission is completed. The combination of the controlled connection and one or more data connections is called a session, and the FTP dynamic rules are sometimes referred to as session rules. The session remains established until the control channel entry is deleted from the state table. During the periodic cleanup of the table, if the session control channel has been deleted, all data connections are deleted. So dynamic rules are created depending on the direction of your client server and mode, active or passive. So we have a client FTP active mode where the firewall will create a dynamic incoming rule after parsing the incoming port channel, provided the port channel is RFC 959 compliant. The rule is deleted when the server initiates the connection or the rule expires. The server FTP active mode, the firewall will create a dynamic outgoing rule after parsing the incoming port channel. In the client FTP passive mode, the firewall creates a dynamic outgoing rule when it reads the PASV command response that's sent by the FTP server, provided it has previously seen the PASV command from the FTP client and the PASV command is RFC 959 compliant. Once again, the rule is deleted when the client initiates the data through connection or the rule expires. The server FTP passive mode, the firewall creates a dynamic incoming rule. The number of seconds that you have that you can configure before TCP connections timeout is anywhere from 1 to 240. This will say how many seconds that an unestablished TCP connection remains active if no more packets matching the connection are sent or received. The number of seconds before UDP and ICMP echo connections timeout, that can be anywhere from 1 to 300. It also specifies in time how long that UDP or ICMP echo virtual connection remains active if no more packets matching the connection are sent or received. The option will reset to its configured value every time a packet that matches the virtual connection is sent or received. And the valid range, again, is 1 through 300. Configuring the firewall status control, if you want to, you can have it where your users are allowed to disable the firewall. It is disabled by default, and we strongly recommend that you keep it this way. But we do have this as an option if you need to have what we would call an escape hatch that you can allow the users to disable the firewall if need to. The desktop firewall product has a DNS blocking feature that you can configure to block specific domains. Please understand that this is not to replace any type of real web gateway product like our web control feature that comes with ENS. But you can put some different specific domains in here, and you can separate them with a comma or a carriage return. It will ignore if I have any duplicate entries. It will add a rule near the top of the rules list that will block the connections to resolve to any specific domain name. So we will not allow it to give the IP addresses where you can actually resolve them to the domain names. We have a feature in the desktop firewall where you can configure defined networks. Your options is that you can put an IP address, or where you can put a single IP address, a subnet, a local subnet, range. You can even put a fully qualified domain name, and you can define these by any IPv4 or IPv6, and you can create any local IP address. Basically, this is to be used where you can define that this is a trusted network or it's an untrusted network, and when we go to create our rules later on, we can use these defined networks within the rules without having to define them over and over again. All we have to do is, if we wanted to add another IP address to possibly a trusted network or an untrusted network, we can go into the definition for that defined network and just add that IP address or the range, and then you have where it will automatically be applied to any policy that has that defined network assigned to a particular rule. Trusted networks are IP addresses, IP address range, and subnets that our organization considers safe. By defining a network as a trusted network, it creates a bidirectional allow rule for that remote network at the top of the firewall rules list. Once defined, I can create firewall rules that apply to these trusted networks. Trusted networks also function as exceptions to the Mcafee GTI in the firewall. So as best practice, when adding networks to your firewall rules and groups, select defined networks for the network type and take full advantage of this feature. And with that, then you don't have to go and always edit the actual rule to add any of these IP addresses. All you have to do is go and add that particular IP address or information to a specific defined network. Configuring trusted executables is a feature that we have where you can specify executables that are safe in any environment and have no known vulnerabilities. These executables are allowed to perform all the operations except operations that suggest that the executable has been compromised. Trusted executables are executable processes that will ignore all firewall rules. All you have to do is click the little add button to specify your particular executable. When you configure this trusted executable, it creates a bidirectional allow rule for that executable at the top of the firewall rules list. Maintaining a list of safe executables for a system reduces or eliminates most false positives. For example, when you have a backup application and you need to run it, you might have a lot of false positive events that might be triggered. To avoid triggering these false positives, I can make that backup application as a trusted executable. Do note, a trusted executable is susceptible to common vulnerabilities such as buffer overflow and illegal use. Therefore, Firewall still monitors trusted executables and will trigger events to prevent those exploits. To define the executable, all you have to do is create the file name or path, the MD5 hash, or the signature. The firewall catalog, where you can add the trusted executables, is where I can actually go in and configure these by clicking the drop down for the item type select executable, and I can have both executables of applications listed here. The executables can be associated with a container application. So by creating the different executables and applications in the firewall catalog, I can add these to my list of trusted executables. Once they're defined, I can reference the executables in all of my rules and groups. Check your understanding, multiple choice, choose the correct answer. Incoming connections have a default GTI reputation threshold of, is it A, do not block, B, high risk, C, medium risk, or D, unverified? The answer is A, do not block. Check your understanding, true or false. Adaptive mode is enabled by default. The answer is false. Check your understanding, multiple choice. Choose the correct answer. You want to allow traffic with MAC addresses in a list of supported virtual machines. Which option setting defines this feature? Is it protection options, tuning options, or defined networks? The answer is protection options. The key points to remember is the firewall ensures compliance with application and system access policies through the stateful packet filtering and inspection. We have two types of firewall policies, the options policy and the rules policy. Options policies define our basic and advanced firewall settings, for example, all the protection options, the tuning options, the Mcafee GTI reputation, stateful firewall, firewall status control, domain name system blocking, or DNS blocking, defined networks, and trusted executables. The rules policies define the criteria for the traffic filtering and handling, as well as allow the creation of groups to simplify management and provide more granular traffic control. The settings in the firewall options policies are pre-configured but can be customized as necessary.